perfect competition, there is a difference between a market graph and the graph for the individual firm. The market graph includes all the buyers and sellers. The buyers, of course, are illustrated in the demand curve, and the sellers are illustrated on the supply curve. All together, they come together in a market and make decisions on the price of the product and the quantity on of the product. Now, how does this affect the individual firm? Well, if the market is set, what this means is that for the individual firm, they will have no other option than to charge at P star. What effect does this have on the individual firm? Well, let's take a look at price. Since we already know that the price is determined in the market, this means that all individual firms have to be price takers. So, for the individual firm, they have to take this price, and basically that's the only price that they can charge. For the individual firm, this becomes the demand curve that the individual firm faces. What does this mean? Well, here we have a perfectly horizontal price curve because the price never changes. The price never changes because it's set in the market. This means that the individual firm is stuck charging at P star. It will be silly to charge lower, but let's take a look at another possibility. What if the individual firm decides to charge a price of P prime? Well, in this case, P prime is a higher price than what people, consumers, see in the market. If consumers know that all other firms are charging P star and this individual firm is charging at P prime, no one would want to do business with this individual firm. This means that the demand curve that the individual firm faces is perfectly elastic. The individual firm has to be charging a price of P star. Therefore, in perfect competition, my price equals my demand. Furthermore, since the price is constant, we can derive that our marginal revenue will also be equal to our price. Think about it. Every time you sell one unit, you're basically getting the same price for that extra unit. Therefore, the additional revenue you get from each additional unit is just the price. We can use this graph also to determine the optimal level of production if we just add our marginal cost curve, shown here. The intersection between marginal cost and marginal revenue will give us our optimal quantity for this firm. We can also expand these ideas to analyze something that we have seen before, which is profits. Our profit equation is profit equals total revenue minus total cost. In order to use the information from this graph though, we have to modify this equation just a little bit. Let's divide both sides by Q. we will see that we have an identity that we have seen before, which is total cost divided by quantity. This is simply average total cost. Now, we have total revenue divided by quantity. But what is total revenue? Total revenue is price times quantity. If we divide by Q, then we end up having just price. So, we end up with price minus ATC equals profit divided by Q. If we just take our Q and multiply it to the other side, now we have a modified profit equation, which will be pi equals price minus ATC times Q. This will allow us to use the information in the graph to figure out if we have a profit, a loss, or a normal profit. Now, let's analyze this graph by including our average total cost, like it's shown here. Now, we start on our analysis by identifying our optimizing quantity, which is in this case is 5. We get this quantity by identifying our intersection between marginal revenue and marginal cost. Now, we need to identify what our average total cost is when we are producing 5 units. For that, you simply have to take the dotted line shown in this graph and see where it intersects with ATC. Once you identify that, you will be able to fill in the equation for profit. We already know our quantity is 5. Let's take a look at what our price is. In this graph, our price is 18, shown by the blue line. Our average total cost, which is represented by the intersection between our dotted line and ATC, in this case is 16. So if we simply subtract 18 minus 16, we see that we have a positive number. In this case, it's a positive 2. Together with our quantity, it gives us our profit, which is $10. Now, if we move our average total cost curve on this graph, we will get different scenarios. Let's take a look at the scenario shown on the graph now. Here, our ATC curve intersects marginal cost and marginal revenue at the same spot that our profit maximizing quantity is, at point E. Therefore, if they're intersecting at the same spot, we can conclude that our profit equation will be $18 minus $18, which will give us 0. This means that when our ATC intersects at our optimal point, we will have a normal profit. We can also have the following scenario shown on the graph now. In this scenario, we now have to identify again what our average total cost is. Remember, follow the steps. Look for your optimal point of production, that is point E, where marginal cost equals marginal revenue.
Follow that point to find your profit maximizing quantity. And then use that dotted line as a guide to show you where this dotted line will intersect your average total cost. In this case, since our average total cost is higher than our price, you can see that we had to extend our dotted line. And this will show us that our average total cost is somewhere around $21. If we plug this information into our profit equation, we can find out that this will give us a loss. Notice that the price remained at $18, but our ATC is now $21. 18 minus 21 will give us a negative number, which is -3. So we see that in this example, we have a loss.